here for the NYSTEEA Tech Ed Teacher Talk. We have 4 awesome presenters today that are going to share some important information with us and some really cool projects. So we're so excited that you're joining us. This will be recorded. The resources are going to be shared on the NYSTEEA website, and we'll explain that in a second. Caitlin.
All right, so as Liz mentioned, welcome to the second NYSTEEA Tech Ed Teacher Talk. To get us started, I just wanted to introduce some of the people behind the scenes so you had a name to a face. So I am Caitlin Bowen. I am the upcoming Vice President for NYSTEEA. Liz Gallo just muted herself. She just spoke just a second ago. She's the immediate past president. Matt McGuire, he is our current president. Matt, want to unmute and say hello? Okay, we'll come back.
Button. Hi, it's on the mute button. There you go.
Hi, Matt. And then Melissa Hurt is our Capital District Vice President.
Hello, everyone.
And Matt Stark, he is our Website Manager and immediate past Vice President.
Hi, everybody.
All right, so those are your peeps behind the scene that put together these, the 2 Tech Ed Teacher Talks. We're excited that there was so much involvement last time and there's so much interest to have a second one. We're excited to hear from our presenters like Liz mentioned. Each one will go over a 5-minute presentation and go over a couple of things that are relevant to you right now. So, and then we'll allow for 3 minutes to answer questions. So if you can drop any of your questions into the chat box, and I ask that all of you are kind of cognizant of your mute button and, you know, pay attention to whether or not you're muted or unmuted. So we're just going to do question and answer through the chat box, please. Once the presenters are finished, like Liz mentioned, we're going to go into breakout rooms with those presenters for about 15 minutes. So you're able to have a small group time to either ask questions to the presenter or to just have conversation amongst yourselves. We do want to quickly mention that the project ideas and resources that are shared today hopefully will help you with the end of the school year. A lot of us are wrapping up right now, but we are not guaranteeing that any of the programs or websites that are recommended are EdLaw 2D compliant. So we highly recommend that you work with your district's data privacy officer about any, you know, new resources that you are looking to use with students to make sure that they, 1, approve and 2, is compliant. And so I'm going to pass the mic back over to Liz, and we're going to get started introducing our first presenter.
Yes, I just want you all to be aware that all of the resources that our presenters share and all the resources from our last talk are located at nystea.org/COVID-19. So you can head there to find anything you need for anything anybody's sharing. Our first presenter is Mr. Steve Barbado from ITEA. He is going to talk with us today about the new technology and engineering literacy standards. So, Steve, take it away. I'm going to stop sharing my screen and allow you to share.
Will do. Hi, everyone. Thank you so much for this opportunity. I do want to say that 300 seconds is ticking away. So normally I talk very fast and I get really pumped up for these things. And when you're given a 300-second kind of hit here, it's really interesting to hit it. But I'm going to hit share, and we're going to bring up a live Standards for Technological and Engineering Literacy graphic that helps us explain what we're doing and how we're doing it. Hopefully all of you have been onto the ITEA website. On the website, if you type STEL in the search window in the upper right-hand corner, it'll take you to the resources page. I also put a link in today's chat to that page. There are several tabs there with different information that I'll flip to in a second. I want to also introduce one of the attendees today. That's part of our executive committee of the ITEA Board of Directors. That's our president, Dr. Philip Reed from Old Dominion University. Also on the session, we have our president-elect, who is Dr. Virginia Jones from Patrick Henry Community College in Virginia. And then we have our immediate past president from Minnesota, Michael Sandell. So thank you very much for supporting me on this and attending. And if there are times that you want to jump in, just go ahead and unmute and feel free to jump in. So on the standards for technological and engineering literacy, we were given the task 2 years ago with funding from the NSF to basically take the standards for technological literacy, move them into standards for technological and engineering literacy as we've been using in our field for the past 12 to 15 years. Even though those other standards didn't have it in the title, there was a lot of engineering design that was part of that. And I'm probably not telling anything new there to most of you in the audience. So when we went at it, we knew that there were too many standards, TOO many, and we wanted to condense those. And we used surveys, we used presentations, we held focus groups to bring that all together. And to succinctly, in this short time in the presentation to kick it off, we've come up with a presentation that I want to move down here too. In the core, we have the standards for technological and engineering literacy, defining the role of technology and engineering in STEM education as the byline. With that, those 20 standards were powered into these 8 standards. So from the nature and characteristics of technology and engineering, the core concepts, the integration, the impacts, the influence, the history, the design, and the applying components are our 8. Every child, every level, grades pre-K to 2, 3, 5, 6, 8, 9, 12, need to be taught each one of these standards. So we're talking about every student, all levels, all abilities being taught these. We're going to be doing those through our technological and engineering habits of mind. And these are the practices. So as we look at the next level out on that chart, you're going to see systems thinking, creativity, making and doing, critical thinking, optimism, collaboration, communication, and attention to ethics. This chart, along with the previous chart, are a must. So the standards with the practices must be taught to all children. And then moving through, we're going to take these and run them through the gamut of a variety of contexts. So as we take these, we're going to add contexts. And the contexts, as you can see, are pretty broad, from agricultural and biological technologies to medical and health-related technologies. As you can see, energy, power, material conversion and processes, computation, automation, artificial intelligence, and robotics. The key is this: whether you're in New York, whether you're in Oswego or Buffalo, or whether you're in New York City, or whether you're in Virginia, or whether you're in California, Montana, or Utah, or Minnesota, doesn't matter. There are different parts that you want to be able to emphasize to meet your local needs and differentiate. The contexts allow you to do that. So if you're going to really focus, I saw Tanya is on this, Tanya Lackey is on this call. The project that she's involved with, that we're involved with through Hofstra right now in the NSF, is a AP Computer Science Principles course. You know, that fits the context across the board here of several of those. It fits in the top one with computation, automation, artificial intelligence, and robotics. It fits down in information and communication. It even fits when we get into the built environment and material conversion and processes, because we're putting a technology and engineering hands-on component to that AP Computer Science course. So it's pretty cool. That's the way that we have moved into really delivering a pretty dynamic way of introducing these standards. And there's a nice little graphic here that I'm going to play for you, and that is the core standards with the revolving practices must be taught to all children. And we're going to do that through all of the different contexts in a variety of ways. The one key is you don't have to teach all the contexts, but you must teach all of the standards, and you must teach all the practices through the relevant context that you want to be able to teach. So that's my down and dirty presentation on this. I think I just hit my 5-minute mark. We're open to questions. I did have one question I should have asked at the beginning, Liz and Caitlin, and that is, can we put Phil Reed, Michael Sandell, and Virginia Jones into the same room with me? And then for the next 15 minutes, I think that's what you were going to do. Or is it going to be at the end of 15 minutes?
Yep, at the end, after our other presenters talk, we'll move everyone to rooms, and everyone will choose what room they want to go to. So they'll
Gotcha.
do that.
Gotcha.
Easy.
So what time do you think it would be? Okay, so we'll just stick around. Got it. Okay.
Thanks.
All right.
So let's see. We have a comment from our audience. They love the inclusion of context. I love the idea of optimism. I don't think we talk about that enough with kids. How do you be optimistic that this is going to work and make that happen? Other thoughts from the audience? You can throw it in the chat.
Thanks
Greg
so much,
loved your-
Steve. That was a great overview. I know it was, hard to condense that presentation into 5 minutes. Again, this is to help make you aware. If you weren't aware of the new standards, definitely go to the ITEA website and check it out. Obviously, they're more than willing, the ITEA team to help you, guide you through it if need be. Just wanted to make sure that all of you are aware of these new standards. We thought it was an important piece to definitely make sure that NYSTEEA group knows about it.
So David asked a good question. He said, how do these impact New York? Something that the NYSTEEA team has been working on has been to get new standards adopted by the New York State Department of Education. And we're looking for help on putting together some sort of organized effort to share these standards to get them adopted in New York State. There's a lot that goes with that, but it's something that we've been thinking about with the board and always value all our members' opinions. And if anyone wants to help out with that, please reach out to us.
So Steve, one question for you. How do these relate to the NGSS, the Next Generation Science Standards?
Excellent question. Do you mind if I share my screen real quick? Won't take long, I promise.
Go ahead.
Yep. Just going to pull up real quick. As you look at the ITEA website, you're going to see a resources tab on the STEL page, Standards for Technological and Engineering Resources. It took a little while to load there. Come on back in. Come on.
The weather. Just blame it on the weather.
Blank down here. Okay. This is what you call Murphy's Law, right? So under the STEL, there are crosswalks that we've already done to the NGSS, okay? To the NCTM math standards, to the ELA.
You haven't shared your screen yet.
Oh, that's why. Stephen Barbado. Sorry. Thank you. Forgot to hit that share. All right. So in the overview, things are working here and we've got it. There's content here. What I'm saying is right now, for some reason, when I click on this, I'm coming up with a blank. I'd love for you guys to try it and let me know if you're seeing any resources in here, because that's where the verb matrix is. That's where the FAQ is about the STEL in this resources area. That's where the crosswalk is, the NGSS. And we actually had on the writing team representation from National Science Teaching Association, American Society for Engineering Educators, National Council of Teachers of Mathematics president, as well as a bunch of others that were actually on the 40-person writing team.
Wonderful. Thank you
for
so
sharing.
much. Great
Check those
resource
out,
for all of
everyone.
us.
All right, our next presenter is Nathan Smith from Elmira High School. He's going to be talking about VEX VR for robotics and some interesting other concepts. Nathan, take it away.
All right, hi everybody. I'm going to go ahead and share my screen here, and away we go. So yes, just real quick about me. It's my 17th year of teaching. I teach Project Lead the Way courses, POE and SIM. I have a robotics course, and I'm also a VEX robotics team advisor. So I'm going to kind of very quickly just go over what VEX VR is and some of the resources that are out there. And then if you want to come to the small group, I'll explain a little bit more about how I'm using it. And I realize that probably most people, I don't know if you're going to introduce anything new at this point of the year, but I'm going to go forward. So what VEX VR is VEX created this virtual reality environment called, and it uses VEX Code, which originally when it came out a month or two ago, it was just Scratch-based blocks, but they've just recently released text-based coding with Python, and there is a little bit of a back and forth between the Python code and the Scratch code, so students can start to see what's happening. It's based on VEX Code, so if you are using VEX robotics in your classroom or with competition teams, it's kind of the same type of code, but it's a virtual robot. It's not connected to a physical robot at this point. And they also, VEX has released a bunch of new items for various grade levels, from elementary all the way to high school. So It is all web-based. There is no program to download, so it can be done on tablets, Chromebooks, computers, iPads, and things like that. And there is no login or registration, so there are no issues with 2D compliant. You save the programs to your device, not to the cloud, so there is no issues with that. Oops, my mouse is touchy here. So it comes with a pre-built robot, and they basically put some sensors on there, and as they're doing it, they're adding stuff like the electromagnet wasn't there at the beginning, and they've added it. So they kind of, I think VEX sort of pushed this out early just to get it out there for everybody to be using while we're on this closure. And as they're working on it, they have some more stuff. So you can see some of the different sensors and the different activities kind of go along with that. The other part of it that goes along with it is there are virtual playgrounds. These are a few of them. There's a couple more. And there's different views within the playground. So they've set up and they are continuously creating the virtual playground. So there's a grid map, and you can use coordinates and things like that. It works on your Cartesian coordinate system and kind of relating to how the robot moves. There's these electromagnet or metal discs that you can use electromagnet to pick up and move. They've created wall mazes. They have castles that you can drive around or knock over. And they've just come up with some dynamic mazes where each time you reload the maze changes. So if you really get into some advanced programming, the students would have to make something that works on any maze or any castle layout, not just a standard one. And that also helps kind of maybe move away from some kind of universal answers, which is what I've been finding a little bit out there. So this is what the program interface looks like. This is just a Scratch one. The Python one looks very similar. And if you've used Scratch, if you've done code.org or anything like that, it's very similar. Or if you're using the Edison robots that I know Liz loves, and I use those in my classroom too, it's very similar to that as well. But it's nice that it's all virtual. You can kind of see across the top, there's some of the different parts to where the things are located, all right? So that's just kind of a quick overview. As far as the teacher resources, they have a VEX Code VR teacher resource page, which has a pacing guide, kind of a letter home explaining to parents what it is. And there are also activity answers. The pacing guide kind of looks like this. It's not really so much of a pacing as far as how much time you think it'll take. So I struggled a little bit with that, trying to figure out how long these activities would take my students. But they break it down kind of in like an order. So it's really more of a pace of how to go through them, not necessarily how long they all take. And there are three kind of categories: movement, sensors, and then advanced. They do have some standards on there as well, or kind of what's going on with them. It tells you what map they use and things like that. So there's a pacing guide that's kind of there to help you as a teacher. What I did was I picked a handful of them from different categories to kind of walk my students through. I didn't do all of them. The email home doc is just kind of a thing they created that looks sort of like this. I broke it up. It's a couple pages, and it basically just explains to, you can use it as an email or whatever to parents if you want to, or you could send this to your students, and it kind of has some ideas about what's going on, what the playgrounds are, the activities, why to use it, and some vocabulary. And this, everything that they provide is, this is on a Google Doc, so you can edit it, change it to a Microsoft Doc if you're on Office or whatever, and make it whatever you want it to be to give out to the parents or stuff like that. The activities, kind of the page sort of looks like this, and I just kind of try to show each of them. So they're in alphabetical order, not difficulty order, but there's a couple different kinds, and you can kind of see some of the stuff. Some of them are labeled as new. And there's the dynamic wall maze where each time they do it, the wall changes. And there's various different things. The robot dance party has been a favorite of robotics forever, right? And some different stuff like that. So when you click on one, so here's like the disc mover challenge. If you click on it, their activities look like this. Again, they're all Google Docs. So if you want to change them, I modified a lot of mine to try to get them away from the standard answer. There's a lot of teachers that have put a lot of resources out there that I'll show in a second. But they're going through how to solve these. And so the kids can just kind of like follow the teacher tutorial and hand you in a code. So I've always kind of changed level 3 to something that is unique to the students, using their student ID numbers or a birth date or something like that. But this is kind of what it looks like, and you can modify it. The levels, you can choose to leave the levels on there. So if you're middle school, elementary, you can do the lower levels. If you're high school, you can do the higher levels. and things like that. And here's the Storm the Castle one for the advanced and stuff like that. They always kind of have some helpful hints, which are cool too. So, and then, you know, and I'm kind of cranking through this because there's a lot to just kind of overview, but there are a bunch of resources like, so how do you get started? What do you know? Right in VEX VR code and that screen, there's a bunch of tutorials. They're pretty much all set up right now for the blocks, but they're starting to add the Python resources in there. So here's, you know, kind of a whole bunch of tutorials to go get the resources from. There is what's called the knowledge base. So VEX has created this for all their products, and there's you can see there's a couple different categories for getting started, general things on VR, and then if you're using blocks or Python, and then some of those educator resources. And then there are a couple of, these are just two that I've sort of found that I've directed my students to. Mark Johnson's done a great job with some of his videos of how to use it in this Education Public. They've got a bunch on there. There's a lot of tutorials and videos about how to use it. And recently there was a VEX Code VR Facebook group that was started by Mark Johnston. And when I took the screenshot last night, it was up to 208 members, and it's continuing to grow and stuff like that. So there's kind of that resource. So I forgot to start my stopwatch, so I don't know if I hit 5 minutes or if I'm long or short, but that's it for that.
Awesome. Thank you for sharing. That is awesome. That is, I mean, it's so impressive what companies can do so quickly and have done so quickly to help teachers. So Scott Reed is here in the chat with us from iDesign. He reminds us that VEX 1, 2, 3 and VEX Go will be coming out this summer and is for earlier grades, pre-K, K, 1, 2, which is awesome, which is so exciting. Any other questions, thoughts?
So, you did see
So there was,
oh, go ahead.
no, go ahead, Nathan.
Well, I saw in there, they were talking about the board and stuff like that for IQ and stuff like that that Scott's talking about in there. And just kind of reiterate, the VEX Code is sort of its own thing. It's not like hooked up to a robot. The VEX Code VR, and it's not something that you would use directly into either IQ or the VRC, either with Robot C or with VEX Code for Cortex or V5. So it is kind of its own thing, and the codes are not necessarily made, like, not designed to work with a physical robot when you get back to a classroom.
But we're still teaching all those computational thinking concepts,
right?
And strategy and problem solving, which is really important.
Somebody asked if it's free. Right now it's free. I have no idea. I'm not a salesperson for VEX, so I don't know if they're going to eventually charge for it, or if it's going to stay free to try to kind of get people in and then move to purchasing physical robots and things like that. I don't know that. So, but right now it's free.
Scott Reed from iDesign did respond to that question. He said, no, it was $99 right now. So definitely reach out to a vendor and get more resources. But Nate gave us a great overview to get us started if we were interested. Thank you so much, Nate, for your presentation. Looking forward to, interacting with you in a smaller group.
All right. Thank you.
All right.
Caitlin, that response to $99 was for the field. The VR code is free. It's a free download. And I just put a link to it in the chat. So anyone can download the VEX code VR. That's free. But I was responding to the extended field for VEX IQ, which is now going to a 6x8 field. So if anybody wanted to order the extra half field, that price is $99. Sorry.
Thank you so much for clarifying. Thank you.
Cool. Awesome. Love this group. This is amazing. So next up, we have Leaf from Peru Central School District, and it's going to be talking to you about teaching robotics in distance learning.
Hey everybody, a lot of faces I know, a lot of faces I don't. Hopefully we can all meet face to face sometime. Let me share my screen. Okay, so I teach a robotics class, and we don't have a kit that we buy and use as a canned curriculum. So I use predominantly Arduinos because they're cheap and you can reprogram them. And if they break, $8 gets you a new one, that kind of thing. I made a sub page on my main web classroom page that I'll link in the chat later on. And if we go into the breakout room with me, I'll get into more specifics. But I typically have a bunch of skill builder assignments that introduces kids to Arduino. And at the tail end, right before we went to remote learning, we had a lot of skill builders under our belts already. I usually did like paper copy forms, and there's linked right there if you're interested. But when we went to distance learning, I discovered Tinkercad circuits, and it blows my paper copies out of the water. So I'm definitely gonna use those in the future. They're sequential, they build on your skills, they do self-paced guided tutorials with graphics on where to put wires and stuff. So they're fantastic. Link right there on my site, you can check them out. Before we went to distance learning, I really try to focus my robotics class on robotics in industry, so where you could see them in manufacturing or automation. And the kids had just finished assembling a 3D printed robotic arm. And they assembled it, but they didn't get to code it. So when we went to distance learning, we used Tinkercad circuits to then code their Arduino-based little robotic arm. So we can go through the steps. I did not create, this is a really cool design. It's called the EasyBot, and a guy designed it, and they're available to 3D print. I converted his file to a Fusion 360 file though, so that's on my website if you want to download it. I have the kids edit this a little bit in the class, so they kind of customize it themselves, which is a cool part before they 3D print. The first one we made, the MK1, was a little underpowered. So next year we're gonna do, again, on EasyBot's site, the MK2. It's just a little bit bigger servo motors. If you click on that link, I have it pulled up here, I think. He has his files just in STL form, but it also has great directions. So I'm thinking in the future, you could have the kids, for solely in remote learning, give them pre-made kits, and we could do like group building online from their house. In the breakout rooms, I'll go over my learning sequence that I went through. But I found that works the best is I would give the kids an assignment skill builder that they would do from a pre-recorded video, try to do it on their own. And then the next tech class we had, we met for a live meeting where the kids then would share their work with me, and then I could upload it to a 3D printed robot from my garage. That kept the kids in track and on pace and in sequence, and they could see what worked and what didn't. And then their final result is they had a code that they could then upload to their own robot, and it would work. The second half of the robotics class where we ended is with a product called the DoBot Magician. And this is a great product if you're interested in how do I get kids to experience programming an industrial robot, but have the size, be able to fit in the classroom, and the budget. It's relatively inexpensive compared to bigger robots too. So my learning sequence, I just have links to if we were face-to-face. I have a bunch of resources for this product. But how I did it remote is way different. I kept with that sequence of giving them an assignment, they do it on their own, and then we meet with a live classroom to plug and play, and they would give me their code for the robot over a Google Doc, and then I would just take it in a live classroom and upload it to the robot. So we started with just getting familiar with the coordinate system and its work envelope. We went through a bunch of end effectors like pick and place with a suction cup. So they're controlling different end effectors. We migrated, again, this one kind of comes with the robot, the claw end effector. So you're figuring out how it rotates to pick up an object. And then we ended up with a complete work cell where we used both of the robotic arms that my school has and a conveyor belt attachment. to make a kind of like an automated little factory. So all that code was through a Google Doc uploaded to me in a live classroom. You notice at the end, the last robot has a 3D printed end effector on it. Pretty unique for the DoBot. It's very easy to make your own attachment at the end. So that end effector was not made by my robotics class, but my engineering and manufacturing classes would design the end effector and then send it to me, and I could 3D print it. And I have their files, some of the better ones on my website. And then it could fit into the DoBot itself. So this was a little electromagnet. This class didn't code it, but they talked about the mechanics and how it could fit and work and what would its application be, that kind of thing. 5 minutes is definitely up, but right before I get cut off here, when I was going to present this, I didn't want to give you guys an example of something that no one has, so I contacted DoBot, and they gave me a discount code for educators. I don't want to puff out my chest. I don't get any money, but the discount code is Sorghel 2020, and then you could get a percentage off. It's already pretty inexpensive, but that helps if you're thinking about, okay, what can I do remotely with my kids that works? So that's on my website as well. I can go into more in depth if we do the breakout room with me later though. All right, I'm done.
Awesome. Thank you so much. So I personally have the DoBot at my school, and the kids love it. It was easy to pick up and use. So your resources are definitely going to help some of my teachers as well. One of the questions was, are you using this with middle school or high school?
I'm using it with high school. However, there's different ways to code the DoBot. You can use Blockly, you can use Python, you can use like a position put in place. So it's depending on your level, you could definitely see it applied to the middle school level too.
Awesome. And then one more question from Nate. How long did it take to print a single robot arm?
So I have a Dremel 3D printer for the tech room, and a complete robot uses 2 build plates. So about 8 hours per robot arm. How I did it is the piece that the kids could customize was just their end effector piece. So before the school year started, I would just throw on part 1 of all the prints, and everyone has that already, and then they would just print their modified part.
Awesome. All right.
Thank you. Thank you for sharing. That was really informative. I like how you described how you're using your live sessions and independent work time. That's really important. That I think it's really difficult for a lot of teachers to figure out how to do that and how to do that effectively. But it sounds like you have a nice workflow going there. So thank you for sharing. Up next, we have John from Hammondsport, and he's going to talk about hands-on building at home and some cool stuff that he's done with his students. So, John.
Okay. I really struggled at first, the whole concept of coming home and doing what I do in school, as I'm sure all of you did too. But I did come up with a couple things. I want to share my screen here. And let's see. All right, I'm not doing something right. New share.
So are you looking for the hands-on building? Can you click on that tab?
Yeah, right there. Nope, it's not. What am I doing? Oh, there we go. No, it's the other one. There we go. And I'm gonna back up because that's actually the end. All right, I'm gonna start with the project that's on the first screen is something that I came up with for my 7th graders, an introduction to technology, where I got them all the components for that little fan, the motor, the switch, some wires, a battery holder, and a fan, and I had them design a personal fan for themselves. First of all, we talked about circuits, and then we put it together. They decided they had to have some kind of a structure to hold it all together, or it was just going to be this floppy mess of wires. And so, you know, as I said, the first thing we had to do is we had to go over a circuit, you know, the basic parts of a circuit. We talked about the different kinds of wire, and that you had to twist the wire at the end to make it behave like one, connect it to the terminals. We did not solder it. Obviously at home we didn't solder it, although I had one kid that asked if he could. And you know, at school this would have been done via demonstration. I handed them all the pieces, and you know, I had my own pieces, and we demonstrated, and we just went over them together till everyone had a working fan. At home it was a little bit more difficult. So what I did is I shot a video of me doing it, which I posted to Google Classroom. And then I also made a little handout that showed each one of these steps, step by step. And I gave them both of those so that they could go on and build their fan. And then what they had to do was, like the bottom right picture there, they had to send me a picture, or during live class time, they would just turn their video on and they would show me their working circuit. And that was the first thing that I evaluated. At school, like most of you, this is my solution at school. We would have gone Autodesk Inventor, and we would have 3D printed that structure that holds it together after they worked on some basic design. You know, what did that structure have to do? They had to take careful measurements of the motor and the switch and all the things that had to go in it. And that's the way we did it. And we were right in the middle of that, actually, when we, you know, March 13th came and we were all done. So I had to figure out a way to do that at home. And what I came up with was build it out of whatever you have at home. So they still did. I was fortunate enough that we're a small school. I had a small group of kids. I made up these little bags of parts, and the school had them delivered to the kids in my classes. So they had the parts, they put the circuit together, and then I said, you know, find something to make the structure out of, because you don't have 3D printers at home. Some of you may not have any tools at home. Some might have tools, some might not. So we had to make it so everyone could do it. I found a used yogurt cup laying around the house, and I made one out of that. I made a couple examples to show the kids so they didn't have to start from scratch. And then I made another one, you know, the roll left after the foil's gone, a little piece of cardboard at the bottom. And, you know, I assembled another one out of that. And then I showed the kids both of those examples, and I said, go ahead and make something. And actually, to go back just a little bit, the one thing that I did find in addition to that is the kids really appreciated being able to do something hands-on as their teacher did. I'm very much a hands-on person, always have been, and that's what we do in class most of the time. And so the kids were very appreciative. I even got some great feedback from some of the parents thanking me so much for something besides having their kids sit in front of a screen the whole time. And so I met with them 2 days a week in live meetings, and then in between, I'd give them these assignments, and then I would check their progress at the next class until we got them all done. Some of the student solutions, you'll see they're a little crazy. The one, big tall one, the kid obviously had some extra wire laying around the house. That particular parent was really into it, helping his son with that thing. He wanted to be able to hold it and have it blow down on top of his head, so he made a really big one. The plane up there was kind of cool too. You know, the kid can just hold the plane, and it runs backwards so it blows out on his face. And then a couple of the other ones over there to the left. So these are ones that kids actually came up with. And I actually had a 90+% rate of completion. Everyone came up with something. And again, they were very appreciative to be able to do something hands-on. Another thing I did, and I'm going to end on this. Actually one more, and then I'm going to end. I then had them, you know, talking about evaluation. How do you evaluate that? I had them take pictures of the fan from the top, front, and side, and then I had them convert it to a very rough 3-view sketch of their fan. And, you know, last time we had this session, someone went over SketchUp or something like that. They could certainly have used SketchUp maybe to do something a little bit more professional. But then again, I had kids that had poor access to the internet, and I had kids that just were sick of doing stuff on computers. So I said, just do a sketch. It's not even using a ruler, really. You just draw the lines as straight as you can and label the important dimensions and go. So I turned it into a little bit more than just the build. And then I also teach materials processing, and I just put these up because I thought these were pretty clever. I do something very similar. In class, when I'm at school, I do a project very similar to it, but we use Raspberry Pi. And what I do is I have the kids take their Raspberry Pi and make it do something, and then 3D print something that goes with it. It may just be a case, and that's pretty open-ended, and I do leave it that way. It could be a case for the Raspberry Pi, and maybe there's a sensor on it so that when someone walks by, a buzzer and a light come on. Or it could be, we made robots. Some of them made robots. So I got some motors with wheels, and they made a little robot, and they drove around with that. So at home, what do you do with that? I did not have Raspberry Pis to give the kids at home. So I just said, build something. And these are two of the things that the kids actually built. The little pizza oven over there on the left, just made from some scrap bricks and ceramic materials laying around that kid's house, to a doggy ramp. That dog is getting old and can't get up on that girl's bed anymore, so she made that doggy ramp so that the dog could get up on her bed. And she actually had the measurements of her bed and everything. So there certainly are ways to keep things hands-on with the kids in these times, and most of them responded pretty well. You know, evaluation of something like that's pretty hard. I can't really see it. The craftsmanship is not really there like we would expect at school. But, you know, they got something done, and the kids were appreciative and the parents were appreciative. So that's it. I don't know if anyone has any questions.
Thank you. Great projects. I loved how authentic that was and how you described your struggles. I also love how you talked about how you can't just let kids with this giant project and let them go. You have to have those check-in points, or else they feel like they don't know what to do, and then it feels like no one's doing anything. So those check-in points, like we would in a classroom, need to happen online too. Marianne asked, how did you get the materials to the kids? Can you just share that quickly again?
The electrical components for the fan, my school distributed things for us. If we had any sort of printed material or any sort of materials we wanted to get in the kids' hands, they had two options. First of all, they had the school resource officer in the school foyer, and during certain times of day, people could come in and get those things, and anything that was left after a certain amount of time, he would go out and deliver. So he actually went around and delivered everything. I don't know if that's available at your schools. Again, we're a small school. We're kind of fortunate that way. But yeah, I guess the thing is, planning on the fall, if for some reason in the fall, we do some sort of a hybrid, or we start the year at home or anything like that, we will be able to plan that, and we'll be able to get those materials out to kids in advance and not have to kind of think it backwards.
Right, that's the hope. I know people have been sending stuff home on school buses with the school lunches, collection bins outside the school where families can come and pick up things. We mailed some stuff here to kids in the Bronx to work with, and that worked out really well. I know the library here is taping stuff to their fence, like little kits to their fence, and people are picking it up and doing science kits that way. But thank you for sharing.
You're welcome.
So we are going to move into our breakout rooms to talk more. I'm going to explain what we're going to do that. You are all going to rename yourself with the number of the breakout room you want to go to. So how to rename yourself: if you find your little picture of your face or your name and you move your mouse onto it, you'll see the 3 dots on the top of your picture. You can click on that and it'll say rename. You are going to rename yourself with the breakout room you want to go to. If you can't do that, we'll help you in a minute find another way to get to a breakout room. I promise everybody will get there. Cool.
Thank you.
So you're welcome. So our 3 breakout rooms. So our first breakout room is with our friends at ITEA, talking about the standards for technological and engineering literacy. So if you want to go to that breakout room, you are going to find the 3 buttons, 3 dots, click rename, and you're going to put a number 1 before your name if you want to go to that breakout room. The second breakout room is on VEX VR with Nate. If you want to go to that breakout room, put a number 2 in front of your name. If you want to go to the third breakout room about robotics and distance learning with Leaf, you put a number 3 in front of your name. If you want to go to breakout room number 4 about hands-on building at home, you put a number 4 in front of your name. And if you just want to have a conversation with your colleagues, just a general conversation that isn't specifically on these topics, like an open-ended, not guided conversation, you can put a number 5 and we'll send you to just a general breakout room. Got it? Caitlin is going to talk you through some of the group norms in our breakout rooms as I move everybody.
Great, thanks, Liz. So as you are renaming, just a couple things once you are in your breakout groups, be generous, be kind, be courteous, make sure you are also listening and sharing. You can learn just as much by, actually taking a back seat and listening to some things that are going on with other people. Everyone plays a role in moving the conversation along. If there needs to be, a separate conversation between 2 people, exchange contact information. You can send each other a private message in the chat. Share your mic, then mute your mic. Be positive and solution-oriented. We are all going through rough times right now with COVID, but make sure you are trying to stay positive and solution-focused. Stay on topic for that breakout room. And at the end, if the topic is not for you, no problem. It's okay to find a different session and move into a different breakout room. Even if you wanted to just go into that general breakout room and have a general conversation, we welcome you to do so. So Liz, once they are in a breakout room, they can just go to the bottom of their screen and switch which breakout room they're in, correct?
No, they have to come back to the main room. So leave your breakout room.
Okay, they have to go back to the main room.
Yep.
Yep, so if you need to just, leave your breakout room and go back into the general room, Liz and I will be there, and then we can put you into a different breakout room. Okay, it looks like there's still a number of people that have not renamed themselves, which breakout room they would like to go into. Please click that ... Liz, do you want to back up one slide so they know which breakout room is which?
Good idea.
Thank you so much.
Caitlin, this is Tanya Lackey. Quick question.
Yep.
As everyone's getting started. The topics presented today are wonderful, and I'm having a really difficult time trying to decide on which ones. And so I chose a session. But my question to you is, are the individual breakout rooms being recorded today as well, so that we can kind of go back and look at the conversations happening in those others that we're not in?
I might be able to answer that one for you, Tanya. We weren't sure the time we did this a couple weeks ago, and it looked like it only recorded the one that I am going to because I'm the one that's recording this session. So
great. Which one are you going to?
I'm going to the general one, number 5. But again, nobody has to follow me in there.
But our co-hosts have the option to record when they get into a room.
I will record in one.
So
thank you.
And I'll record too, and then I'll send it to you.
Perfect.
That'll be great. Thanks.
All right, we're going to our breakout rooms. If you don't make it there, that's fine. We'll talk about it. So enjoy your time in the etherwebs.
How we doing, everybody? It looks like people are trickling in. Hey, John, good to see you.
Hey, how's it going?
Good, how are you?
Hanging in there. Having fun?
Always, my friend, always.
I saw that there's a lot of options for robotics and distance learning. That's awesome. I was looking at using VEX VR myself in the fall if we had to still be online.
Yeah. So it looks like we're staying steady at about 15. So I just wanted to say hi to everybody. If I haven't met you, my name's Matt Stark. I am transitioning out of the NYSTEEA VP role and into more of a web development role. So if there's anything ever wrong with the website, I'm the guy that you will shoot an email to and I'll fix it right away. The website will be updated at the end of the session with all of the resources and all of that kind of stuff. So that'll get done probably this afternoon, as long as all the video feeds and downloads and all that stuff work correctly. So I'm here just to provide a place that if you have a question for NYSTEEA specifically, you can ask it to me. I'll do my best to answer, as well as just I'm a general tech ed teacher too. I teach middle school and high school. I run robotics clubs and all sorts of stuff. So I also see that Brittany's here. It's nice to see you, Brittany. You want to introduce yourself, or in case anybody has questions for state ed?
Brittany Kitterman. I'm the Associate in Instructional Services for Technology Education. Also in the room right now is Kelsey Roman, who is the Assistant for Instructional Services here at the department as well. We're here to provide assistance in any way that we can. If you have questions, I might not have the answers right away, but I'm happy to get those answers to you. One thing that I have created, I've been in this position since the end of January. So in the physical space, not that long before we went virtual. I'm creating a listserv so that as guidance or information becomes available for technology education, I can get that out to you guys as soon as possible and share that information. So I put my email address on the last meeting we had, and I had quite a few respondents for getting added to the listserv. And I'm going to do that again today. I'll put my email right in the chat box. So if you're interested in joining that listserv, feel free to send me an email and I can add you.
Thanks, Brittany. So for people that have been around a while, Brittany took over for Phil DeTellis, who retired. And Brittany has done awesome. I met her. I told the same story before. I met her in the fall. I don't think I've met Kelsey in person yet, but they've been doing an awesome job for our program. So we really appreciate the support from state ed as we try and figure out distance learning, as well as maybe our standards are changing in the future and all of that kind of stuff. So thanks for coming, Brittany and Kelsey. We appreciate it for sure.
No problem. The other thing that we work with for folks, because I know there's some high school people in the group, is the reapproval and approval applications for any approved CTE programs that you might have. So if anybody's embarking on that, you can also reach out to us for that. Because I know those reapproval applications for some programs are coming up June 30th.
So I do see a question in the chat there for you, Brittany. The word for getting back to in-person hands-on next year. We're curious about vocational tech as well as tech ed and other places as well.
This is the million-dollar question. We still don't have guidance pertaining to this right now. And Kelsey had a great talk about this in one of our TAC meetings we had the other day. But there are regional, basically task forces that are working on this. Kelsey, do you want to speak to that a little?
So the Board of, as you've probably heard, there is a task force by the governor, but at the state ed level, the Board of Regents has called for some regional meetings based on the reopening of schools for the fall. And I can put that link into the chat. So if you are more interested in diving into that a little bit more and seeing what comes of that, you can absolutely go visit that. But essentially the goal of those regional meetings is to voice concerns about considerations for the fall. What do we need to be thinking about in terms of all aspects of returning? So that could be in terms of teaching and learning, digital equity, hands-on, CTE. So all those things are going to be discussed in those meetings. And from those meetings, State Ed will be developing guidance for the reopening of fall, which should be coming out after the Board of Regents meeting on July 13th. So you should be looking for some guidance coming to you by like mid-July time. So I will put that link into the chat. So if you're interested in reading more about that, you can do so.
Can I ask like a general question? So I teach middle school. I've only been doing this for about 3 years, and I have like 250 students, you know, every other day kind of thing. How do you do the hands-on? How do you afford the hands-on, like buying a little of this, buying a little of that? How do you guys find that work?
Are you talking specifically about distance learning or just in general?
Just in general. I mean, distance learning actually has been easier because
Right.
I'm like, go build a Rube Goldberg at home with whatever's in your house.
Right.
So it's been easier than doing it in the class because, again, 25 kids 5 times a day, you know, how do you make that?
What is your budget like to purchase materials?
Nothing.
Okay. Pretty similar here then. We have the same, and 2 of our middle schools have a significantly lower tech ed budget than one of them. And believe it or not, our middle school tech ed teachers do dumpster dive stuff. Like we process pallets. People give away pallets, and we process that material for middle school kids to make projects and all of that kind of stuff. So it's finding cost-effective means to be able to do that. And in my school specifically, we do the big clip project. It's kind of a classic middle school project where the kids make a giant clip. I still have mine somewhere in my office here. But those springs are like $1 a piece now when they used to be 25 cents or 50 cents. So it's trying to figure out how to do that, because if you add that up for 200 kids, you got $200 just in springs for the year, right? So you got to come up with things that you're either willing to do dumpster dive type stuff or supplementing with some pretty cheap supplies that you can get. I've heard of other. Go ahead. Sorry.
There's a lot. I mean, around us, there's lots of local industries. There's a company that does sub-assemblies for a bus manufacturer, and they have these giant crates that they just toss in dumpsters. And if I've, need something, I'll call them, say it's for the school, and they'll set aside some crates. Sometimes they're built with better 2x4s than I can buy at Lowe's. So just seeing what local manufacturers and industries are getting rid of that can be useful to you.
I've heard of other tech ed teachers that ask kids to bring stuff in too, if they have any contacts with adults or themselves, and whatever the supply is. Some teachers have talked about doing bonus points with that, or somehow incorporating it so there's some sort of stimulating reason to do it. But you can bring it back on the kids and ask them to bring things in too. I see Matt's talking about times. My district's talking about similar things if we don't go back full time as normal. Like kids show up every other day. I've heard that hybrid idea. Is anybody else hearing that hybrid idea where kids they show up every other day, and teachers also somehow rotate too and do online one day and in person the other?
Yep. My school's talking about that as well.
Yes, our administration has also said that if we're not in school and we're at home, we're going to have Zoom meetings for each class period from our homes.
My daughter's school is testing this week where they do every other day for the high school, and it's 25-minute class periods instead of, the full 42. So they only have 2 hours of live school a day.
Yeah, the idea being thrown around in central New York, I'm in the Syracuse area, is kids they're coming, the hybrid idea is when kids come to school, they go to one classroom, they're in that classroom for the day, and the teachers end up rotating around to meet each kid, so that way they don't have the issue of, you know, getting something happening in the hallways or whatever. So I have a hard time sitting still for that long. I can't imagine like I teach middle school as well, 8th grade, and just like 8th graders in one room and eating in that room too, and all of that kind of stuff. It'll be interesting to see. And as Brittany said, we don't really have guidance yet, nor I'm kind of like, I kind of expect that, right? Because you don't really know what's going to happen until it happens. So you're trying to come up with all of these plans to, what if this is the idea? What if that's, like, you got to come up with multiple solutions.
That's the same idea thrown around in our school district right now too, is having the kids stay in one spot, and then they're saying, oh, we've got you're going to be teaching construction systems. I don't know if I'm like cutting material and bringing all that stuff with me to those classes, or how that's really going to work. Am I bringing those tools with me every day? Am I just going to store them in that class? And that's the tough thing with elective classes. If I've got 6 kids taking that class, but they're all in another room throughout the rest of the day, we're not sure how that's going to work yet. So
it looks like our breakout room's closing in, I don't know if everybody else sees that, but in about 15 seconds or so, and we'll be pushed back to the main room. So please reach out if you have any questions at all. I've really enjoyed these talks. I'm glad they're working so well. The first one had like 140 people. This one's got almost 100. It's been awesome to get together as a big tech ed group.
Yeah.
Welcome back. You're back in the main room. Everyone's coming. Still have people in breakout rooms.
Awesome. Thank you for being so considerate about your mics. We really appreciate that.
Cool. Everyone's back. Awesome. I love traveling through the interwebs. It's pretty cool. Hope you enjoyed your chat in the breakout room. Hopefully you met some cool people, heard some great things, got some questions answered. Caitlin just shared with us in the chat a post survey. We would absolutely adore if you took that post survey. Our results from our last survey were really informative to help make this one happen. We are looking to do another session sometime in the future, knowing that school is ending in a few weeks and everyone's kind of tired. So we're excited that you joined us here today. Anything else, Caitlin?
Nope, I just dropped the link one more time. We really hope that you check us out on the NYSTEEA website. All the resources will be posted in a few days. Again, the session was recorded. All of the resources that our presenters shared will be uploaded to that website as well. Thank you so much for your time. We really appreciate it. We know that all of us are short on time at the end of the school year. So thank you so much to our presenters for sharing some information on what they've been doing. And definitely make sure that you keep on reaching out to your peers. We are here for each other. You know, tech ed community is pretty tight, so make sure you keep that going. And thank you again so much for your time. So sorry that we ran a little bit over today, but it was great content. So thank you, thank you, thank you. And we hope to see you again in either a couple weeks, either at the end of June or after the 4th of July. We were kind of in discussions whether or not, you know, we wanted to do it in a couple weeks or, you know, at the beginning of July. So thank you again. We'll stay on for a few more minutes if you had any lasting questions, but that concludes our second Tech Ed Teacher Talk. Thank you so much.